Here we are with our last unit, that is sixth unit, second part of electrochemistry. In this unit, we will see the different types of the cell, reversible and irreversible cells, the sign convention used, what are the different types of the reversible electrodes that we use, the Nernst equation, then the derivation of the EMF and a single electrode potential, standard hydrogen electrode as a reference electrode, then the thermodynamic quantity to be calculated, and the concentration cell. There are two types of concentration cell which we are going to study, electrode concentration cell and electrolyte concentration cell. The concentration cell of two types again, the concentration cell without transference and with transference. And finally we will end at liquid junction potential. Now the objective to study this is that in the previous unit we have discussed about electrolysis, electrical transport, conduction, Ohm's law, Arrhenius theory, transport number, how to determine the transport number, Ostwald dilution law, Kohlrausch law, Debye-Hückel theory. Now here we are studying different electrodes, cells, their functioning, types of the cell, electrode reaction, EMF of the cell and the free energy. Now, electrochemistry. Electrochemistry, it is a branch of physical chemistry that studies the relationship between electricity as a measurable and quantitative phenomena. It identifies the chemical change with either electricity considered as an outcome or electricity used. This reaction involved electric charges moving between the electrodes and the electrode. It deals with the interaction between electrical energy and the chemical change occurring. When a chemical reaction is caused by an externally supplied current in an electrolysis, if an electric current is produced by the spontaneous chemical reaction, it is called as electrochemical reaction. The chemical reaction where electrons are transferred directly between the molecule or atom or oxidation reduction reaction. So in electrochemistry, it describes the overall reaction when individual redox reactions are separate, but they are connected to the external electric current and electrolyte. There are various types of the cell. Galvanic cell. A galvanic cell, it is a device in which free energy of a chemical process, it is converted into electrical energy. Usually, such a cell consists of two electrodes immersed in one or more electrolytes. When the electrodes are connected externally by metallic conductor, current flows from one electrode to another, and inside the cell, chemical change occurs at surface of the electrode. On joining the electrodes externally, oxidation occurs at one electrode and reduction occurs at another electrode. The electrode at which oxidation occurs is called as negative electrode or cathode, while the electrode at which reduction occurs is called positive electrode or anode. The reason for this nomenclature is that oxidation accomplished by liberation of electrons which are given up at the electrode at which oxidation occurs. The electrode which acquires negative charge, reduction. It is accompanied by elimination of electron acquiring the positive charge. Now electrochemical cell. This is electrochemical cell. Consider a copper dipped in the solution of copper sulfate and zinc dipped in the solution of the zinc sulfate. Two metal rods, these two metal rods, they are connected by a metallic conductor. When a bar of zinc is dipped in the solution of copper sulfate, means if zinc is dipped in copper sulfate, then the reaction is zinc plus copper sulfate giving zinc sulfate plus copper. This is irreversible reaction. In this, zinc is oxidized to give Zn2 positive. Copper is reduced to give Cu atom. The electrons are released, which are released in the first half cell reaction, they are utilized by the second half cell reactions. Now, let the two half reaction they occur in separate compartment like this. which are connected by a wire. The current will flow for an instant and then stop. The current stops flowing because the charge in the two compartments. The electron leave the left compartment would become positively charged. The right compartment receives electron and become negatively charged. Both these factors oppose the flow of electrons. Now what is voltaic cell? Voltaic cell is known as galvanic cell, in which electrical current is generated by the spontaneous redox reaction. So, we know the reaction zinc plus copper sulfate giving copper plus zinc sulfate. The cell is represented as copper in copper sulfate, double line zinc in zinc sulfate. Now, this cell converts chemical energy liberated during the redox reaction to electrical energy. It has the potential equal to 1.1 volt when concentration of zinc and copper, both the sulfate, that is unity 1 mole per decimeter cube. This is known as voltaic or galvanic cell. Suppose the external opposite potential it is applied to this cell. Then we find that the reaction continues to take place till the opposing voltage reaches the value 1.1 volt. When the reaction stops altogether and no current will flow. Any further increase in the external potential again start the reaction, but in the opposite direction. So, it now functions as electrolytic cell, a device for using electrical energy to carry out the non-spontaneous chemical reaction. A galvanic cell. It is an electrochemical cell that converts electrical energy of a spontaneous redox reaction into electrical energy. These reactions occur in two different portions of the Daniell cell. Reduction half reaction occurs at copper electrode, while the oxidation half reaction occurs at zinc electrode. These are half cell or redox couples. Now, at each electrolyte interface, there is a tendency of metal ion from the solution to deposit on the metal electrode, trying to make a positively charged. At the same time, metal atom of the electrode have tendency to go into the solution. Now, at equilibrium, there is a separation of charges depending on the tendency of the two opposite reactions. The electrode may be positively or negatively charged with respect to the solution. A potential difference develops between the electrode and the electrolyte, which is called as electrode potential. When the concentration of all the species involved in the half cell is unity, then electrode potential is known as standard electrode potential. It is known as standard electrode potential. The potential difference between the two electrodes of a galvanic cell is called as cell potential, and it is measured in volts. Cell potential. It is the difference between the electrode potential, reduction potential, and of the cathode and anode, known as cell EMF, electromotive force, when no current is drawn through the cell. And we can write E cell is equal to E right minus E left. The potential of individual half cell cannot be measured. We can measure only the difference between the two half cell potential that gives the EMF of the cell. There are two types of the cell, reversible and irreversible cell. The electrochemical cell may be reversible, it may be irreversible. In reversible cell, it is implied that the chemical reaction occurring may proceed in either direction depending on the direction of flow of current. If we apply the EMF from an external source, then the greater than the opposite, then the chemical reaction will be reversed. The driving force and the opposing force, they may be infinitesimally different. When these requirements are satisfied, the cell is said to be reversible. Otherwise, it is irreversible. So, now there is a cell reaction, and we can decide whether it is reversible or irreversible if the reaction is opposed. The cell can be represented by a different notations. We know that. If we write a single line, it represents a phase boundary between metal electrode and its solution in which it is dipped. If we indicate double line, it means salt bridge or a porous partition or any other medium permitting the ion flow. Then concentration are written below the electrolyte solution. Pressure difference, if any, it has to be written. Temperature, if it is, it has to be mentioned. Like this, cell can be represented. Now, how to calculate the EMF? Just now we have seen that E cell is equal to E cathode minus E anode, or right hand side EMF minus left hand side EMF. Now, what is the different types of the reversible electrode? We have just seen the reversible electrode. Now, what are the different types of reversible electrode? For thermodynamic treatment of galvanic cell, it is essential that these cells operate in a thermodynamically reversible manner. We want reversible cell. So in order to find out if a given cell is reversible or not, it is connected to the external source of EMF acting in the opposite direction. Any cell will be reversible if it satisfies three conditions. If the opposing EMF is exactly equal to the cell itself, the current is given out by the cell and no chemical reaction take place. If opposing EMF is infinitesimally smaller than the cell itself, an extremely small current is given by the cell and correspondingly small amount of chemical reaction takes place. If opposing EMF is greater than that of the cell, then externally small current flow through the cell in the opposite direction and a small current of chemical reaction also takes place in the reverse direction. Now, an electrochemical cell, it consists of two various types, that is metal ion electrode, metal amalgam electrode, metal insoluble metal salt electrode, gas electrode, oxidation reduction electrode. We will see all these one by one. So first of all, gas electrode. This is gas electrode, hydrogen electrode, hydrogen gas electrode. We can construct similarly oxygen, hydrogen electrode also, chlorine electrode, like this. Gas electrode. In gas electrode, hydrogen gas, this gas, it is continuously bubbled. This hydrogen gas is continuously bubbled through the solution of HCl. Its concentration is 1 molar. 1 molar of HCl solution, hydrogen gas at 1 atmospheric pressure is bubbled in the solution of 1 molar HCl. A inert metal like platinum, we have to dip the inert metal platinum in this for the electrical contact, as it is not attacked by acid. It does not participate in the electrode reaction but helps in making the electrical contact. It is just for making the electrical contact. It is not any electrode. It is just a wire to make the contact. Hydrogen electrode. Hydrogen being a gas, it is a special device. It is made in order to make the potential difference between gas and the solution. It should be measurable. It consists of placing a small strip of platinized platinum foil so that it is halfly immersed in a solution and half surrounded by the gas. The finely divided platinum foil absorbs hydrogen, and in that condition it behaves as if it was a solid electrode of the gas. It freely permits the change from gaseous to the ionic state and vice versa. Similar electrode, if we pass chlorine gas, it will be chlorine electrode. If we pass oxygen in H2O, then it will be oxygen gas electrode. Now metal ion electrode. An electrode of this type consists of metal rod dipped in the solution of its own ion. Metal dipped in the solution of its own ion. Metal ion electrode. Metal dipped in the metal ion solution. For example, zinc dipped in zinc sulfate, copper dipped in copper sulfate, like this. If the metal rod behaves as negative electrode, the electrode reaction involves oxidation and the above equilibrium shifts towards left. So concentration of M positive ion will increase. Now, instead of the pure metal, amalgam of the metal may be brought in equilibrium with the ions of the metal ion in solution when one gets an amalgam electrode, this one. This electrode is reversible with respect to sodium ion. If the amalgam is saturated with the metal, the electrode is equivalent to one containing pure metal. And the electrode potential is determined by the activity of the metal ion. Amalgam electrode. It has certain advantages that on the pure metal electrode. Strengths in the solid metal, they are absent in amalgam, so equilibrium can be established rapidly. Metals like sodium, potassium, which react vigorously with water, so we can use amalgam formation. And a small quantity of the impurity which may produce an anomalous behavior in pure metal, they are sufficiently diluted by the amalgam formation. So it gives more accurate results. Now the metal, insoluble metal salt electrolyte. That means we have to dissolve metal in its insoluble metal salt. The electrode consists of the metal and a sparingly soluble salt. Insoluble salt means sparingly soluble salt of the same metal. Sparingly soluble salt, Hg2Cl2. So Hg dipped in Hg2Cl2. Calomel electrode, the best example of this type. Metal insoluble salt, metal electrolyte. It can be easily constructed, it can be easily formed, set up in the laboratory. Mercury of high grade purity, it is placed at the bottom of the glass tube. We have to take one glass tube having two side arms. Mercury is placed, purified, highly purified mercury, it is placed at the bottom of the glass, having a side tube. It is known as calomel vessel. This vessel is known as calomel vessel. A solution of KCl is introduced above the paste. From this side, we have to introduce KCl solution. The concentration of the solution, the KCl solution which we are introducing, its concentration may be normal or decinormal, 0.1 normal, or it can be saturated. Three types of any one in the three, normal, decinormal or saturated. We have to introduce that KCl solution into this. Why? Because its standard values are reported in the literature. That's why we want these three types. And preferentially we take saturated KCl solution, so no problem with the preparing of the solution. There is no error. So we preferably take saturated KCl solution, which should be introduced from the side arm over this mercury. A tube containing mercury and fused with the platinum wire. This is a tube fused with platinum wire containing mercury. This is the tube. At its lower end, to serve as a contact between mercury of the electrode is formed. The tube should contain sufficient mercury to sink the platinum contact. The side tube, it is filled with the agar-agar salt bridge solution, agar-agar of and KCl, solution of agar-agar and KCl, which has to be filled in the salt bridge. This tube is connected with a salt bridge and the other electrode, the potential of which to be determined. So this is all about the calomel electrode. In the exam, you can be asked to write down the construction of this calomel electrode. Now, oxidation reduction electrode. This is also another electrode which we use in the laboratory. The term oxidation reduction, for those electrodes in which the potential is developed from the presence of ions of the same substance in two different valence states, means we have to choose here the ions having two different oxidation states. It is set up by inserting an unattackable metal, again platinum. The function of this wire is to pick up the electron. It is just for the electrical contact. It is not again electrode. Platinum is never electrode. It is just for the electrical contact. For example, quinhydron electrode, QH2. So what we have to do here, just we take the beaker and in that we keep platinum wire and add a pinch of quinhydron powder. Then an equilibrium is set up like this, quinone and hydroquinone. And this is reversible. So oxidation reduction both take place, quinone and hydroquinone. The electrode reaction is like this. So actually we can't observe this electrode because you will not see like other electrode this electrode, because here you just have to keep the platinum wire in the solution and add a pinch of solid quinhydron in that. Don't try to dissolve it, it will not get dissolved. It will just simply interconvert into quinone and hydroquinone, giving rise to oxidation and reduction both the reaction. So here what we have seen up till now we have seen the different electrodes. Then how to calculate the EMF of the cell, that is E is equal to E cathode minus E anode. Then in the last talk we have seen the single electrode potential also. In that we have seen the standard hydrogen electrode. Then standard electrode potential also we have studied. And from that electrochemical series we have seen. Now the cell potential is used to determine the EMF of the cell reaction. So now you should be habitual with different electrodes, how they are working, how they are constructed. You should be able to know all this.